Difference identities are another set of identities that can be used to simplify expressions, solve equations, just like your Pythagorean identities and your cofunction, even and odd, etc., etc. There's a lot of identities out there. Sum and difference is what we're going to be talking about today. You guys are going to use sum and different identities to simplify and solve trig expressions and equations. These identities you do not need to memorize, you just need to know how to use them. So still, the only identities that you're responsible for knowing are, and that's called the Pythagorean identities, as well as the quotient identities and the reciprocal. So you still only have to know those three. This again will be given to you. So we're going to start out with the sum and difference identities for your sine ones. Okay? So the rule says that when you have sine of a plus b, a and b could either be variables or they could actually be angles on your unit circle. But the formula is sine a cosine b plus cosine a sine b. If you're subtracting, sine of a minus b is a similar setup. Sine a cosine b minus cosine a sine b. And from there, you use the identities to find the exact values. So for example, sine of 75 degrees. Is 75 degrees on your unit circle? No, it is not. However, I can use the sum and difference identities for sine and try to figure out, okay, using the angles on my unit circle, using the degrees on my unit circle, are there two angles that I could add to get 75 degrees or subtract to get 75 degrees? 30 and 45. When I add those together, doesn't that make 75?
Yes.
So if I wanted to find the exact value of the sine of 75 degrees, I want to use the sum and difference identity for sine and add 30 degrees and 45 degrees. Since we chose to add two angles to get 75, I want to use the identity up here. And instead of writing A, I'm going to write which angle? 30. And instead of B, I'm going to write 45 because this is set up as A plus B. Does everybody see that? So I'm going to write out the formula. I'm going to fill in, and then from there, I'm going to simplify. So this is going to be sine of 30 degrees times the cosine of 45 degrees plus the cosine of 45 degrees times the sine of 30 degrees.
Cosine 30.
Oh, I have, yeah, sorry. These are backwards. My mistake. Thank you for the catch. Sorry, cosine 30, sine 45. Knowledge of your unit circle. What is the sine of 30 degrees? 1 half. So it's going to be 1 half times, what's the cosine of 45 degrees? Square root of 2 over 2. I'm going to add that to the cosine of 30 degrees, which is?
Square root of 3 over 2.
And what's the sine of 45 degrees?
Square root of 2 over 2.
You see how, again, knowing your unit circle is, it has not gone away. It's still there.
I need to learn it.
Okay? You know it. Then you just multiply. You multiply fractions, you multiply straight across. 1 times the square root of 2 is over 4. And then what's the square root of 3 times the square root of 2?
6.
Square root of 6 over
4.
And that's your answer. That's it. That is the exact value of the sine of 45 degrees. Okay? You could also write it as one fraction because they have the same denominator. Either one would be acceptable. So that's how you use the sign identity for sum and difference. You just need to, again, you got to use your knowledge of the unit circle and say, okay, what two angles can I add to get that or subtract? Let's do a sine of pi over 12. You got to know your radians, okay? First off, are there any over 12s in our unit circle? No, it's either 6, 4, 2, and 3.
Pi over 4, pi over 3, because you can change both of them to 12.
Okay, so you're saying add them? So, you said pi over 4 and pi over 3? And add them?
Yeah, you use common denominator,
Okay, so I gotta get a common denominator. Well, clearly the common denominator is
right? 6 and 5 is
12. So then that's gonna give me a 3 pi over 4 and a 4 pi over 4. Does that give me pi over 12? But if I
Add them.
adding them doesn't give me pi over 12. But I could do what? Potentially get pi over 12.
Subtract.
Subtract them. Would I be subtracting pi over 4 minus pi over 3? The same way it is now?
No.
No. What would I need to do? There we go. So, if I did pi over 3 minus pi over 4, then that would give me a 4 pi over 3 minus a pi over 3, which gives me pi over 12. So those are the two angles that I want to use. So that's sine pi over 3 minus pi over 4. Questions? Using the identity, that's sine of pi over 3 cosine of pi over 4 minus the cosine of pi over 3 sine of pi over 4. I am trying to find the exact value of sine pi over 12. What's the sine of pi over 3?
Square root of 3 over 2.
I'm going to multiply that by the cosine of pi over 4.
Square root of 2 over 2.
That's going to get subtracted from the sine, from the cosine of pi over 3. What's the cosine of pi over 3?
1/2.
And what's the sine of pi over 4?
Square root of 2 over 2.
And again, I multiply. This is going to give me the square root of 6 over 4 minus the square root of 2 over 4. And that's my exact answer. Or I could write it as one fraction because they have the same denominator. Square root of 6 minus the square root of 2. Questions? Pretty straightforward, right? As long as you can figure out the two angles, whether you're adding or subtracting, I give you the identity, and then, of course, unit circle. Cosine's identity. For the sum for cosine, it's going to be the cosine of A, cosine of B, minus the sine of A, the sine of B. The difference is similar. Cosine A, cosine B, plus sine A, sine B. Same thing as before. I'm looking for two angles that are on my unit circle that are either going to add to give me 105 or subtract to give me 105. It got to be on your unit circle. Don't know for this to work.
60 and 45.
Adding or subtracting?
Adding.
60 plus 45, is that 105? So then let's use that. I'm going to add 60 degrees and 45 degrees to get 105. That means that 60 is going to be A and 45 is going to be B in the formula for the sum. So that's the cosine of 60, cosine of 45, minus the sine of 60, the sine of 45. Can you guys go ahead and use your unit circle? Give me the exact value of the cosine of 105 degrees. Cosine of 60.
1/2.
Cosine of 45.
Square root of 2/2.
The sine of 60.
Square root of 3/2.
And sine of 45.
Square root of 2/2.
So my final answer should have been the square root of 2 minus the square root of 6 over 4. Yes?
Yes.
Yes. Now for the radians. I got to try to figure out what two angles either add or subtract to give me 11 pi over 12. 11 pi over 12. What two angles on the unit circle you do that? So there are two angles that we came up with were 5 pi over 4 and pi over 3. Subtracting them, as you can see off to the left, that becomes 15 pi over 12 minus 4 pi over 12, which does give us an 11 pi over 12. Okay? You definitely want to find what those angles are, so in that way you know what your A and B are going to be. So 5 pi over 4 minus pi over 3. Now, these aren't the only combinations that you can use to get 11 pi over 12. Okay, whichever one you find that works, use that and go. So this becomes cosine of 5 pi over 4, cosine of pi over 3, plus the sine of 5 pi over 4, sine of pi over 3. Now you got to be careful. 5 pi over 4, what quadrant is that in? The third. In the third quadrant, your x and your y are both negative, so that is going to make a difference on your answer. What is the cosine of 5 pi over 4? It's negative. Root 2 over 2. What's the cosine of pi over 3? What's the sine of 5 pi over 4? And the sine of pi over 3. So when you multiply these, a negative times a positive gives me a negative root 2. Over here, I'm going to be adding a negative number, which is just subtraction. And all of that is over 4. So it changes just slightly, but it does make a difference. Last ones are for tangents, okay? Tangent, whew, this is the doozy. And I only say that because it involves a fraction. So the tangent of A plus B is the tangent of A plus the tangent of B, all over 1 minus tangent A, tangent B. The two on the bottom are getting multiplied together. For your difference, that's the tangent of A minus the tangent of B, all over 1 plus tangent A, tangent B. You notice we only have one example because these are the doozy ones. Because if you have any type of radical in your denominator, you're going to have to rationalize. Okay? So go ahead and think. My angles that are going to give me 15 degrees. Okay. So we are going to use 60 and 45. So we're going to do the tangent of 60 minus 45, which means I'm going to use the second of the tangent identities because I am using subtraction. The setup, tangent 60 minus tangent 45, all over 1 plus tangent 60, tangent 45. Now this is where your real skills of algebra come into play here. That's where your real skills are. Because what's the tangent? Well, one, we got to do tangents now. Okay? Tangents. Tangents what over what?
Sine over cosine.
So that's y over x, right?
Yes, ma'am.
What's the y of 60?
Square root of 3 over 2.
What's the x of 60?
1 half.
I'm gonna have to
Keep changing it.
keep, change, flip. That's gonna give me.
Square root of 3.
So right now I have the square root of 3. That is the tangent of 60. Minus, what's the tangent of 45?
1.
That's the easy one. Those over 4s, those ones in the middle, tangent is either positive 1, negative 1. And at least, luckily enough, once you do the work for the numerator, it's the same values in the denominator. So you have 1 plus the square root of 3 times 1. So this becomes the square root of 3 minus 1 all over 1 plus the square root of 3. But I have an issue.
Can't have a radical on the bottom.
You can't have a radical on the bottom. And on top of that, it's not just like 2 times the square root of 3. It's a 1 plus the square root of 3. So in order to rationalize this, I'm going to have to multiply by what? 1 minus the square root of 3. What's that called? The conjugate. And I have to do that to the top and the bottom, which means I'm going to have to FOIL, distribute. Yeah. That's why I said these are the doozies. So I got to deal with tangents, which means I got to do keep, change, flip, and I got to deal with radicals in my denominator. So I'm going to FOIL this very slowly. Square root of 3 times 1. Square root of 3 times a negative square root of 3. Negative 3. A negative 1 times a 1. Negative 1. And a negative 1 times a negative square root of 3. In the denominator, when we multiply by the conjugate, that's going to end up turning into a whole number. So I have 1 times 1. 1 times the negative square root of 3 is a negative square root of 3. Square root of 3 times 1 is a positive square root of 3. Those are going to. And what's the square root of 3 times negative square root of 3? Negative 3. Watch those signs. Those two cancel out. And my numerator, square root of 3 plus the square root of 3 is 2 square root of 3, because you just add like the terms on the outside. What's negative 3 minus 1?
Negative 4.
All of this is being divided by 1 minus 3, which is
Negative 4.
negative 2. Still not done.
You factor out, take out the 2.
Yes, there's a 2 in common in both terms of the numerator, and there's a 2 in the denominator. So I can simplify this, okay? 2 divided by negative 2. So that gives me a negative root 3. And what's negative 4 divided by negative 2?
Positive 2.
And that is my final answer. So what you saw in the last 3 slides are how you use the identities to find the exact value. Okay? Again, identify what angles on your unit circle will either add or subtract to give you 15 degrees or 105 degrees, whatever. Okay? But we can also use these same sum and difference identities to condense, to write an expression for sine and cosine. So open up all your flaps so you can see all the formulas. When I look at this very first example of cosine 51, cosine 14, minus sine 51, sine 14. That looks very close to which sum and difference identity? The one for cosine, okay? Because in cosine, the cosines are together and the sines are together, right? But because it's a minus in the middle,
It's adding.
you're actually adding. So this is going to equal the cosine of 51 plus 14. Because this is our A and this is our B in the identity. And what's 51 plus 14?
65.
So this becomes the cosine of 65 degrees. And that is how we write an expression for that one up there. Now, of course, if 65 was on our unit circle, we would want to keep going, but it's not. What about the second example?
Sine, we're just adding.
Sine, adding. A is what?
2 pi over 3.
And B is?
Pi over 4.
So this is equal to the sine of 2 pi over 3 plus pi over 4. Again, in order to add these, I need a common denominator.
11 pi over
Hmm?
11 pi over 12.
It'll be 12. Okay. So that means I have to multiply this one by 4, this one by.
3.
So what is it? Somebody might have said it. I just didn't hear you.
11 pi.
Did we have that one? 11 pi over 12?
Yes.
Mm-hmm. Then, like I told you, you can use different angles from a unit circle to get like an 11 pi over 12. I think we used 5 pi over 4 and pi over 3, something like that. But we still got the same answer that we would get if we used those two angles. Clearly, the last one is a tangent, right? Is it addition or subtraction?
Addition.
Addition, because the numerator is adding, so we're adding here. What's A?
3 pi over 4.
And what's B?
5 over 3.
Again, in order to simplify this, I need a common denominator, which is going to be 12.
10 pi over 12.
What over 12?
10 pi.
10 pi over 12? I multiply this one by,
3.
this one by.
4.
3 times 3 is plus 4.
13 pi over 12.
13. Very good. And that's how you write expressions as sine, cosines, and tangents using identities as well. Again, if any one of these values after we've condensed it was a value on your unit circle, then you will want to keep going and actually find the tangent of those. But that's how you use your sum and difference identities. You can even use the sum and difference identities to verify an identity. For example, this looks familiar, does it not?
Oh, yeah.
That's your what identity? What? Which identity is that?
Special.
The co-function.
It's one of your co-function identities. We can actually verify the co-function identity now that we know the sum and difference identities. Remember, when anytime we verify, we always start with the more, which is the left of the right. It's the left, okay? That is a cosine difference identity because this is A, this is B, and we're subtracting. So the identity is the cosine of A, cosine B, plus sine of A, sine of B. What's A
Pi over 2.
and B?
X. Pi over 2. X.
And so we can go through this now to verify that this equals sine. What's the cosine of pi over 2?
0.
So this becomes 0 times the cosine of x. What's the sine of pi over 2?
1.
So that's 1 times sine x. What does that become? And that's why it works. So we can use the sum and difference identities to also verify as well. Okay? We can even use them to solve. What I want you to do is I want you to use the sum identity for sine. Simplify this. Simplify the second piece on your desk. Do it now. Use the identities.
Go.
So you should have used the identities. I separated them by colors. Okay? So you should have had the cosine of pi over 4 is what?
Square root of 2 over 2.
And since that's being multiplied to a sine x, that's nothing but like a coefficient in front of this sine x. Okay? What's the sine of pi over 4? Again, that's nothing but another coefficient in front of that cosine x because it's being multiplied. Let's keep going. Well, actually, it's the same thing, right? So this is a plus square root of 2 over 2 sine x. Then this will be a minus square root of 2 over 2 cosine x. Notice anything? Which ones?
So cosines.
The cosines cancel out. Then I have square root of 2 over 2 sine x plus square root of 2 over 2 sine x. I can combine those together. So this becomes the square root of 2 over 2 plus the square root of 2 over 2, which is what?
2 square root of 2.
This becomes 2 square root of 2 over 2. When you add radicals, you add the coefficient on the outside. It's only when you multiply, when you go underneath. How does it simplify?
Square root of 2.
So this is just the square root of 2 sine x equals -1. And because we solved all last week, you should know how to solve this. What should I do? Okay, that's not how I thought y'all were going to go with it. But let me show you what happens when you square both sides. When I square both sides, what does that become? Equals 1. Then what do I do? And then what? Where am I? Back where I would have started by, just started by dividing by the square root of 2. And then on top of that, I have created extraneous solutions, which I got to check. Because when you take the square root, you got to remember it is plus or minus. So I now created some extraneous solutions. But I could have started instead by dividing both sides by the square root of 2. Then I would need to what?
Take it out of the bottom.
Rationalize. So it's really sine x is equal to negative.
Square root of 2 over 2.
And since I'm looking from 0 to 2 pi, where is that?
In the third quadrant.
Third quadrant, 5 pi over 4.
7 pi over 4.
And 7 pi over 4. So you can even use these identities to solve as well. So the main thing is just make sure that you know how to use your identities, not just for simplifying or finding exact value, but for also verifying and solving. And then, of course, you must know and not forget your unit circle.